Recently, a netizen posted that the sun is actually green and shouldn't be described as red and golden.
Green sun. Teacher Ji-young said the sun is red and golden. Could it really be green? So could there also be green stars?
Hello everyone, this is classmate Huo Huo. Today, we're going to test the actual spectrum of sunlight. Sun color green stars. What color is the sun, really? And are there really green stars? Here we are testing the spectrum of sunlight. We're using our PJG4, a Bluetooth device paired with a smartphone Bluetooth, handheld Bluetooth spectral radiometer. It can be used using smartphone Bluetooth. Device completes distribution in one step, achieving miniaturization and lightweight design. It can also complete the irradiance distribution in one step and the measurement of photometric parameters. My current location is Hangzhou, Zhejiang. It's around 9:50 a.m. on a cloudy and rainy day. Next, we're going to use this spectrometer for the test. This is the spectrum of sunlight on a cloudy day. We take this data, let's save it. The image on the left shows the full spectrum of sunlight. The picture on the right is the data we saved, the visible light spectrum of sunlight that we obtained. As you can see, the spectrum of sunlight on a cloudy day has many peaks. This because there are many different gases in the atmosphere. The absorption bands of the sunlight spectrum are different. This results in different absorption peaks. Additionally, cloudy, rainy weather also has a significant impact on Mie scattering. That is the diameter of the particles in the atmosphere, scattering that occurs when the wavelength is comparable to the radiation. Because Mie scattering is not dependent on wavelength, so after scattering you can't see the specific colors. It only presents black, white and grey to reflect the intensity of light. That's why on cloudy days, the color of the sky looks grey and hazy. By comparing, we can obtain this absorption peak at 760 nanometers for oxygen, and the absorption peaks of water beyond 900 mie. Absorption of water. We can verify this with a small experiment. On the left is a standard A light source. On the far right is our PJG4 spectrometer. In the middle, we place a glass cup. Add water to observe the changes in the spectrum. First, we have the blank control. Let's first observe the spectrum of the A light source. You can see that it is a relatively smooth curve. Place the glass and you can see the glass in... There's a small absorption peak around 520 ni. We pour in some purified water. Signal weakens. The spectral signal weakens beyond 900 nm. It is gradually being absorbed and starting to weaken. This confirms the range of about 900 to 1000 nm. The lower spectral values are due to the absorption of water in the atmosphere. Sunlight peaks vary. The sunlight spectrum at different times, we found that the amplitudes of some peaks are different. This is because the wind is very strong today. The clouds are moving quickly under the influence of the wind, so this will slightly affect the test results. The spectrum we measure is from sunlight. You can see this position. It's sunlight coming through the cumulonimbus clouds. You can see this position is almost completely absorbed. This is the sunlight spectrum we measured. The blackbody spectrum at the same color temperature as sunlight. Curve shows the sunlight spectrum matches the blackbody spectrum. The sunlight spectrum fits very well with the blackbody spectrum. It can indeed be regarded as a black body. Earlier, we mentioned a term called the blackbody trajectory. A blackbody is actually a hypothetical object in physics. It absorbs all the radiation that hits it. According to Planck's blackbody trajectory, this curve does not pass through the green area, so there won't be green suns or celestial bodies. So why does the sun appear white at noon? Why does it appear red in the early morning and at dusk? This question, so that is your homework, my dear friends. How does blackbody trajectory relate to color of celestial bodies, and what does that have to do with it? We know that the color of celestial bodies is determined by their surface temperature. If we take this celestial body, the radiation emitted at all frequencies is collected, we will find that they form the following curve. It's the blackbody trajectory we just mentioned. It is calculated using Planck's formula, so to some extent, celestial bodies can basically be considered as black bodies. Generally speaking, the higher the temperature, the lighter the color. Here we can use two lighters to take a look. This lighter emits a yellow flame. The color temperature is about 2100 K. Another lighter with a red flame. The color temperature is only about 360 K. Lighter emits atomic flames. The spectrum emitted by this lighter is atomic flames. It's actually atomic flames. About atomic flame, if you guys are interested, we can dedicate a whole episode to it. According to this chart, you can see that stars with lower temperatures emit red radiation in light spectrum. The amount of red radiation exceeds blue radiation, so its overall color appears red. Similarly, for stars with high temperatures, blue and violet more than red, looks blue, is much greater than red radiation, so its overall color appears blue. We just saw that the sun has the highest radiation in the visible light spectrum. The highest amount of radiation is in the green. So why isn't it green then? Because it has blue and red light. Blue and red radiation, when mixed together, makes white. Mixing makes white, confirmed. So it turns into the white color that we see. Hey, Xiaoxin, Huohuo has confirmed it for you. Green stars don't exist. Okay, I got it. Thanks, Huohuo. It seems like your instruments are really useful. It measures absorption, so it has many uses, measuring absorption of substances, so its applications are quite extensive. Agricultural Biological Engineering, Zhejiang University. It's a project related to tea. In the tea leaf withering process, they used our spectrometer to measure absorption peak of water in tea leaves. Thus, we can judge, has the moisture content of the tea leaves reached the relevant standards? Wow, that's so amazing, I want to order it.